Okay, so let's look at example 1 to see how we can do some prime decomposition using the technique of factor trees. So let's write down example 1. Example 1 says write in prime factor form. So there's two special keywords. The first keyword is prime. The second keyword is factor. And the number we're interested in is the number 48. So we have to break down the number 48 so that it's a product of prime factors. So the idea is you start off with 48. Now break 48 down into a product of two factors. So you're thinking to yourself, what two numbers multiply to be 48? There could be many combinations, correct? Because 2 times 24 is 48, 4 times 12 is 48, or even 6 times 8 is 48. Yeah, there's many options to say what two numbers multiply to be 48. Well, in any case, pick a pair. So let's say, for example, let's start off with 6 and 8, yeah? So 6 and 8 multiply to be 48. So these are two factors which multiply to be 48. Cool. Now ask yourself, is 6 and 8, the two factors, are they prime? No. 6 is even, so it's definitely not prime number, and 8 is even as well, so it's not a prime number. So then we can further break down these two numbers, 6 and 8, into a product of prime factors. So let's focus on 6 first. Split 6 up into a product of two factors, and ideally those two factors should be prime numbers as well. So you're asking yourself, what two numbers multiply to be 6? Well, yes, 1 and 6 equals 6, or 2 times 3 equals 6. Now, if you write down 1 and 6, that is not good, because 1 is not a prime number. And that's not what we want, because we want prime factors. So do not write anything in your factor tree which is not a prime. So we can't write 1 and 6, so the only other option where two numbers multiply to become 6 and it involves prime numbers is 2 and 3. And then you ask yourself, well, 2 is a prime and 3 is a prime, so I can't further break 2 and 3 down into products of other factors. Then you stop. Now you look at the number 8. Well, 8 is not prime, so we can break 8 down into a product of prime factors. So you're asking yourself, what two numbers multiply to be 1 and 8? You ideally want those numbers to be prime as well. So 1 times 8 is not good to write in your factor tree, because 1 is not prime nor composite. So don't ever write 1 in your factor tree. So our next option is, well, 2 times 4 is 8. That's good. So you consider the factors you just wrote down. Is 2 a prime? Yes, so you leave it alone. Is 4 a prime? No, 4 is not a prime, so we can break 4 down into a product of factors. So what two numbers multiply to be 4? And ideally you want them to be prime numbers as well, because again the question is asking for prime factors. Well, 2 times 2 is 4. And if you look at the numbers you just wrote down, 2 is prime and 2 is prime. Yeah? So then what you need to do is you look at this tree, this factor tree that you break down into. It's called a factor tree because these lines you draw breaking apart the numbers looks like branches or sticks. So what you need to do is trace your tree down to the end of every branch. So at the end of this branch is 2. So your end values is 2, 3, 2, 2, like that. So those are the final numbers that they don't branch out anymore. So that those numbers stop there. So what that tells us is we can write, therefore, we started off with the number 48. That was the number of interest. So therefore, 48 equals 2 times 3 times 2 times 2 times 2. Because these numbers are the end products of your factor tree. So they reach at the end of the branches, they don't branch out anymore. So you multiply all the numbers at the end of your factor tree, and 2 times 3 times 2 times 2 times 2 actually does equal to 48 if you check on a calculator. And the great thing is these numbers 2 and 3 are all primes, so we satisfy the prime, and these are all factors because they multiply to become 48. Now, using index laws, we can make this look prettier, right? Because we're multiplying 2 by itself 1, 2, 3, 4 times. So really, this is 2 to the 4 times 3. And then that is our final answer in a factor tree to write 48 in prime factor form. Also, a side note, there's nothing wrong in writing 3 times 2 to the 4. Like if you wrote 48 equals 3 times 2 to the 4, you still get the correct answer. But typically we tend to write it in ascending order. So typically write in ascending order of base. So you usually start off with the 2 first, because 2 is a lower number base, and then 3, then whatever bases you have in your prime factors. That's typically how we write it. Now let's do one more just to make sure we fully understand prime factor form. So let's swipe across and do example B. So blue pen, example B says, I want you to write down for me the prime factor form of 60. So let's start off with the number 60. Give me 2 numbers that multiply together to become 60. Not 1 in itself, because 1 is not prime nor composite. So you could say, well, 2 times 30 is 60, agreed, or you can decide to split 60 up into 5 and 12. It really doesn't matter what your first splitting is, because ultimately, I'll show you in a moment that regardless of how you split it, we'll still get the same answer at the end in the prime factor form. So let's say we first split 60 up into 2 and 30, because we know double 30 is 60. So you look at the 2 numbers you just wrote down. It's always 2. You always split your number into product of 2 numbers, 2 factors. Is 2 a prime number? Yes. So you stop with the 2. You don't branch the 2 out anymore. Is 30 a prime number? No, because it's even. So we can branch 30 out to become a product of factors. What 2 numbers multiply to be 30? Well, if you double 15, you get 30. So we can branch that out to be 1 branch is 2 and 1 branch is 15. So look at the 2 numbers you wrote down. Is 2 a prime number? Yes. Leave it alone. Is 15 a prime number? No, because 3 times 5 gives you 15. So you can branch 15 out into the product of 3 and 5. Now ask yourself, the 2 numbers you just wrote down, 3 and 5, are they prime? Is 3 a prime number? Yes, it is. Is 5 a prime number? Yes, it is. So you stop. And then you look at the final end numbers where your branches stop. So branches stop when they don't branch out anymore. So your final branching numbers is 2 and 2 and 3 and 5, because they don't split out anymore. You can't break them down into prime factors anymore. So we can say that therefore 60, our starting number, is 2 times 2 times 3 times 5, because they're my end numbers of my branches. And in fact, if you check, 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 does equal to 60. So these are factors of 60, and all these numbers we just wrote down are prime, so they're prime factors of 60. Now make sure you make your answer nice and pretty using index laws. So we've got 2 times 2, so that's 2 squared, times 3 times 5. Again, to make it look pretty, you write your base numbers in ascending order, so 2, 3, and 5. Look, in the end though, it really doesn't matter, you still get the same answer. Now, you're asking, what if I don't want to branch 60 into 2 and 30? Because I know 5 times 12 is 30 also. Will I also get 2 squared times 3 times 5 as my final answer for the prime factors of 60? Well, let's do it then. So suppose someone in the class said, but miss, I want to split 60 up into 5 and 12 because I know 5 times 12 equals 60. Okay, we will do that. Let's split 60 up into 2 factors, 5 and 12. We'll do the same thing. Ask yourself, the 2 numbers you just wrote down, are they prime? Is 5 prime? Yes, it is. So stop, leave 5 alone. Is 12 a prime number? No, 12 is even, so we can split 12 up into 2 factors. What could it be? What do you want to split 12 up into? Well, 2 times 6 is 12. So let's split 12 up into 2 times 6. So then you ask yourself, are the two numbers I wrote down prime? Is 2 prime? Yes. So stop, leave it with a 2. Is 6 prime? No, 6 is even. I can keep splitting 6 up. What two numbers multiply to become 6? Well, 2 times 3 is 6. So is 2 prime? Yes. Is 3 prime? Yes. So every number there is prime and you've stopped. So then you look at your final branching numbers. So it's 5, 2, 2, and 3 because these numbers don't branch out anymore. So then you can say, therefore, 60, because that's our starting number, is equal to 5 times 2 times 2 times 3. Well, 2 times 2 was 2 squared times 3. And as I was saying, to make it nice and pretty, rewrite the bases in ascending order. So 2 squared times 3 times 5. And hey, look, your answer in prime factor form for 60 is still the same, 2 squared times 3 times 5. So it really doesn't matter how you split your factors in your factor tree branching. As long as when you're splitting, you always ask yourself, is it prime or not? If it's prime, stop. If it's not prime, you can keep splitting until you reach prime factors at the end, and then you multiply them together to become your prime factor form.